Hello again, welcome to the night class. I'll be your host for today's lesson, Coach Knight. Today we're doing finding the greatest common factor, lesson 7.4 in your Envision Algebra 1 book. If that happens to be the book you're talking about, but no matter what book you're using, we're going to find the greatest common factor of some polynomials. So, our first example, we just get right to it. It says, what is the greatest common factor, the GCF of terms 12x to the fifth plus 8x to the fourth minus 6x to the third? So, first we're going to do the numbers first, and then the variables, and then combine the two, okay? So 12, I like doing a little factor tree, okay? I don't know if y'all have done those back in the day. Did y'all do those? Okay. So 1 would be 2 and 6 and 2 and 3. So we have a 2, and a 3. For 8, we have 2 and 4 and 2 and 2. And then for 6, we have 2 and 3. Okay? How many x to the fifth means there's how many x's? 5. So 1, 2, 3, 4, 5. That's x to the fifth. X to the fourth is 1, 2, 3, 4 x's. And x to the third is 1, 2, 3 x's. Then you just circle what all they have in common. Okay? Do they all have a 2?
Yes.
Yes. They all have at least 1 2. All right. Do they all have a second 2?
No.
No. All right. So 2 is the common factor between 12, 8, and 6. All right. Do they have 1x?
Yes.
Yes. Do they have 2 x's?
Yes.
Yes. Do they have 3 x's? Yes. Do they all have 4 x's? No. So my greatest common factor is going to be 2x to the third. Make sense? Okay. Now, you don't actually have to write all these. You can do it in your head if you know. Basically, you're figuring out what factor, what's the biggest factor that goes into 6, 8, and 12. If you can just know that off the top of your head and say, hey, that's 2, go with it, okay? The variables are actually very easy. So as long as they all have a variable that's the same variable, all you have to do is pick the one with the smallest degree, and that's going to be your common factor, okay? So if it's x to the fifth, x to the fourth, x to the third, hey, we got x's on everything, so you pick the smallest one, x to the third. All right? Any questions? Wonderful. Moving on. Do it again. Let's see here. 15x squared plus 18. So again, you can think in your head, notice this has an x squared. Is there an x over here? No. So we're not going to have x in our common factor because they both don't have an x in common. So it's just the number this time. So 15 and 18, what number, what's the factor that they have in common? 3. Done. That is your answer. Okay? And again, if you need to come over here and say, okay, 15 is going to be 3 and 5, 18 is going to be 2 and 9, and 3 and 3, and you can see they both have a 3. But that is not necessary because, again, most of the time you can do it in your head. Okay? Part B, we have a negative 18, a 6, 24, and we all have y's. Okay? So negative 18, 6, and 24. What would they all have in common? 2. All right. Anything else? 3. Anything else?
The 6.
The 6. Okay. That's usually what I start with. If the smallest number will go into the other 2, that's always going to be your greatest common factor. Okay. So it is 6. And then, like we talked about, they all have a y, so you just pick the one with the, what? Smallest degree. So which one has the smallest degree?
The 2.
The 2. So 6y squared. Okay? Any questions? Everybody good? Alright. Moving on. This time, we are factoring out the greatest common factor. So, did I miss one? Maybe I did. No, okay. I think I missed the first example too, but that's okay. All right, so we are factoring out the greatest common factor of each polynomial. So we're doing the same thing we just did with a little extra, okay? So x to the third, 5x squared, negative 22x. What is my common factor, first off? Well, 1. It is 1. So you don't have to worry about the numbers, because if it's 1, it really doesn't have 1, okay? So it's 1, but what about the letters? Do they all have x's? Yep, so which one has the smallest degree?
Just a 1.
Just x. So all you do is you bring x out front, okay? Now to get we're taking, so it says it's factor it out. So we're factoring it out. So how do you know what goes inside here? You divide everything by what you take out, okay? Divide everything by the common factor. X to the third divided by x is x squared, okay? When you're dividing like bases, you subtract the exponents. 5x squared divided by x would just be positive 5x, and then negative 22x divided by x is just negative 22. Okay? So still found the greatest common factor. This time, though, we're factoring it out. Does that make sense? All right. What is that, the reverse of that we did today? The distributive property, exactly. Okay? If you were to distribute this back out, your answer would be your question. So basically, all factoring is undoing multiplication. Okay? And how do you undo multiplication? You divide. Okay? So that's basically all you're doing here. Part B, negative 16, 28, and 20. What's the biggest number that will go into all of those?
4.
What? Anytime this first one's negative, they always like putting negative out front. Okay? That's just a little based on what textbook you do. If you do positive 4, it's not technically wrong. They just like, if it's negative, to bring it out. Okay? So negative 4. And what about the y's?
3.
Y to the third. And so that's going to go on the front, out front. And then we divide everything by negative 4 y to the third. So, numbers first. Negative 16 divided by negative 4 is positive 4. Y to the sixth divided by y to the third is y to the third. 6 minus 3 is 3. Remember, when, again, dividing, you subtract the exponents. 28 divided by negative 4?
Negative 7.
Negative 7. Y, 4 minus 3 is just y. And then negative 20 divided by negative 4 is positive 5, and the y to the thirds cancel. Okay? Easy enough? All right. Example 3. Factor a polynomial model. All right. So basically, they make a real-life situation fit what we're trying to do here. Okay? So it says, Alani is in charge of marketing for a travel company. She is designing a brochure that will have 6 photos. See, 1, 2, 3, 4, 5, 6 total. The photos can be arranged on the page in a number of ways. There are 2 main square photos, which have a length of x inches on each side. There are 4 narrower photos that are each 1 inch by x inches. Okay, so what's the length here? X inches. Okay, so x and x, because it's a square, right? All right. These are 1 by x. So which side of this is x? Look over here. If this is x, then this side's what? X, which means that must be 1. Okay, x and 1. So down here we have x 1 and 1, X and X. Okay? It says, what is the total area of the photos? So, let's figure that out. What is this up here? If I combined all of this, what would that be?
2x.
Not 2x, but x plus
2.
1 plus 1 is 2. So this is x plus 2. All right, and then going this way, that's what?
2x.
That's 2x. Okay, so the area, length times width, right? So that's just 2x times x plus 2. Okay, you with me so far? Okay, part, I guess if we wanted to, we could distribute that. 2x times x is 2x squared, and 2x times 2 would be 4x. You good? Okay. Example 3, same example. Did I just do?
Is it the same thing twice?
It is the same thing twice. My bad. I put the same picture on there twice. I'm fine. There's B. Okay, there's B. So it says find a rectangular arrangement for the photos when what factoring represents the arrangement. So we just talked about it. What was our area? It was 2x squared. That's not x squared. 2x squared plus 4x. Is that right? Okay. So it says find a rectangular arrangement for the photos. So they kind of did it for us here. Here's all the photos in a rectangle, right? So again, this is x, x, 1, 1, 1, 1, right? And then this side is what? X. So this would be a rectangular arrangement. So notice they took out the what? The x. So it says what factoring represents the arrangement. So if I just took out just the x, what would be left? If I divided by, not by 2, sorry. If I divided by x here and there, we would have 2x plus 4. See what I'm saying? X plus x would be 2x plus 1 plus 1 plus 1 plus 1. 4. And then over here, you have your x. So we just factored, and now it's a rectangle. Okay? All right, well maybe part C says factor out the greatest common factor from the polynomial. What does the greatest common factor represent in this situation? So here, it says the greatest common factor of 2x squared and 4x is 2x. So if, again, I'm going to write it like it was 2x squared plus 4x. So if we take out the greatest common factor, which is 2x, right? You divide by 2x here, you get x. And you divide by 2x here, you get plus 2. Now, what is my arrangement in? You have 2x here, okay? And then you have down here, x plus 2. So it's a little more, it's not straight rectangle, but it's a little more, I guess, more conserving of the space. Because remember, we're making a brochure, right? So brochures are kind of limited on their width space, but they can go up and down. Is that making sense? Okay. And it just says right here, the greatest common factor represents the height of the photos. So that would be your height, would be your greatest common factor. Making sense? Is there a D? Okay, there is a D. It says Alani is in charge of marketing for a travel company. She is designing a brochure that will have 6 photos. The photos can be arranged on the page in a number of ways. So we've found 2 of the ways. Okay? So here was one way. The arrangement had X. Okay? So this one was X times 2x plus 4. All right, when we factored it, this one was 2x times x plus 2. That was the arrangement for that one. It says, which of these two arrangements is more practical use of space on a page of the brochure? So, think brochure. Which one would be more practical to do on a brochure? The second one, definitely the second one. This one would definitely be more brochure-y, is that a word? More brochure ready than this one. This one, the first one would be a little too wide, okay? So, let's see here, we'll try it, we've done enough. So, basically, factoring polynomials, you have to find the greatest common factor first, all right? So you can always take it out and then write down what's left. But what's left you get from dividing the original by the greatest common factor. Make sense? All right. Hope you have a great day at home. See you next time. Stay above the line.